Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 28 in our incredible new tutorial series where you're learning how to drive AI on the edge. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the AI Fusion Lab Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. What I'm going to do is I'm going to give you my solution to the midterm exam that I gave you last week. But before I jump in, I must ask you, how many of you were successful? If you successfully completed the exam, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Now, I will admit that this assignment was a little bit on the challenging side, but I will also say that I have taught you everything that you would need in order to make this project work. It just involved a little bit more analytics and a little bit more critical thinking than some of our earlier assignments which were a bunch of little bitty steps at a time. Now, if you were not able to do it, that's okay. Watch my solution, understand it, and then go back and do the assignment without watching me do it, because you've really kind of got to understand these. Now, the most important thing is that you have to get it drawn out and working on paper before you jump in and start coding. And that's the biggest mistake that I see engineers and students and programmers make, is they hear what you want to do, they jump in and they start pounding out code before they've really defined a logical analytic strategy. And so that's what we are going to do. I am going to get out of your way. I'm going to have a swig of my old motivational juice here. This one, I hope I have enough coffee, because this is a little bit of a challenging program to try to write live in front of the cameras. But what we're going to do is we're going to start over here, and we're going to start on the sketch pad. So the first thing that I am going to do is I'm going to draw the overall frame. That's not good. The overall frame I'm going to draw. This is our frame image. Okay, there we go. And now let's just start labeling some points on here. Now, what do we know this point is? The upper left corner of the frame is the pixel 0, 0, x value 0, y value 0. Over here, what do we have? We have a y value, or we have a x value of the width -1, and then we're still 0 in y. If we come down to this corner, the x is still 0, and the y is h -1. We've talked about this before. And then what is this point down here in the corner? That would be w -1 and h -1. Okay, now what do we want to do? We want to keep that box in the center of the frame. The center of the bounding box should stay in the center of the frame, and we'll move the servos to get that to line up right. But we've got to kind of know what those values are. And so we're going to come here and we're going to say this is the center of the frame. And so what will we call that? I think I will call that X frame C for center, and then Y frame C for center. So that is this value here. Well, what would that be? Well, the X frame center, that is going to be halfway over. So that would be W minus 1 divided by 2, comma, and then the Y frame center would be H minus 1 divided by 2. Now, when we program that, we need to make that integers, but that's sort of our values, all right? So now we've got our corners and our center point labeled, and we've got, in our mind how to calculate them. Okay, what else are we going to have? We are going to have a box, okay? And then here is, let's just say that this is the box up here. All right. Now, what is our problem now with that box? The problem is the center of the box is not at the center of the frame. So what would the center of the box be? That would be X box center, comma, Y. Why? Let me do this neater. That's so not good. Y box center, X box center, and Y box center, an X and a Y value. Well, what would the X box center be? Well, this point is what? That we get on the bounding box, and that was just the X value and the Y value of the bounding box, which we have from last week's program. And then what would this point be? This point would be X plus little w, the width, over 2, and it would be Y plus H over 2, like that. That would be this point. Now, what is the center? The center, the X box center, that, ignore that, okay, that's this corner. So what would the middle box be? I'll write it over here. The X box center would be the left edge, which is X, plus little w. Remember, the bounding box is going to give us a little w, and it's going to give us a little height. Okay, uppercase W, uppercase height is the size of the overall frame, and lowercase w, lowercase h is going to be the width of the bounding box and the height of the bounding box. So the X box center would be X plus little w over 2. Okay, and then the Y box center is going to be the Y value up here, plus the little height over 2. And if we put that in, that will give us this point. So what do I have now? I have the center of the frame, and I have the center of the box. Now, what is the error? The X error, let's draw that in purple. This is the X error, would be this much. So the X error, and let me check something here. I want to kind of get my variables lined up well. And so the X error is going to be equal to where we are in the box, which is going to be the X box center minus where we want to be, which is the X frame center. And then what is the Y error going to be? The Y error is going to be from here down to here. So the Y error is here and the X error is here. The Y error would be very similar. It would be the Y box center minus the Y frame center. Hopefully you guys are drawing a neater picture than I am. And then what do you want to do? Well, if the error is there, you want to move the servo to subtract out the error. Okay, and so you'll look at the error, and if it is positive, then you want to decrement the position of the servo by 1 degree. Okay, now Y error is kind of opposite, because remember, down is up, down is positive, and up is negative, I think, in the way that servo 3 works. And so on the tilt, what you would do is you would do them backwards. Okay, you would do them backwards. And I'll get into that when I actually code. But I think if you look at this, this is showing what we are trying to do. We're trying to drive out the X error by changing the position servo, and we're going to drive out the Y servo by changing the tilt. We're going to drive out the X error by changing the pan. Okay, and so we're just going to set up a loop, and we're just going to click, 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 and drive that error out. And each step will drive part of the X error out and part of the Y error out in each step through the loop. But if you label things like this, then you are well on your way to solving this problem. So let me see here. Let me rearrange my desktop here. So let me get that out of the way and get my keyboard and mouse going over here. And then what we are going to do is we will come over here, and I think you can see that nicely. And so we've got this up, so we're going to come in and we're going to go ahead and save this as lesson number 28, because we're saving our work here, so we always have it next week, a place to start. So I'm going to save that. And then we're going to go to the most excellent, www.toptechboy.com. You're going to click on AI on the Edge with the Raspberry Pi 5. You're going to go to lesson number 27, and we're going to get that code that we ended up with last week. And so I'll get that. I'll come over here and I'll paste it. And then let's just make sure this thing runs. Okay, so there we are. And then if I bring in my object of interest, it's finding it pretty good, right? It is finding it pretty good. It's tracking it. I'm going to see if I want to kind of tweak those. I'm going to see if I want to tweak those values just a little bit, because this job becomes a whole lot easier if you have dialed this in pretty good. So I'm going to go from 25 to 35, because I don't care so much if I get some of those little extraneous dots, because we're filtering on size and we're only going to be using the biggest one. And it works a little better if you have a little bit more margin. You'll get that full region of interest better. And so it's a little bit dimmer today than it was when I did these parameters. And so I think that's going to do it. But you've got to determine these values for your object of interest, because nothing else is going to work in what we do today unless you have this part working. So you see now I'm doing better at getting the whole region of interest. So doing those little tweaks made things work better. Okay, so now what it comes down to is the first thing we need to do is we need to get the servos activated, and the servos, bring the servos to life. And so what are we going to need to do after we do the PWM? What you're going to want to do is from the fusion hat dot what? We want to get the servos going. We're going to import servo uppercase like that. All right, so we've got that set up. Now we need to go ahead and set the pins up. So the pan pin, if you remember from those earlier lessons, was pin 2, and then the tilt pin was equal to pin 3. Now with that, we need to say the pan servo is going to be equal to servo, the method that we just imported of what? The pan pin. And then we're going to have the tilt pin is going to be equal to, I'd like to space this, make it a little bit more readable for us there. Okay, and that is going to be the servo of the tilt pin, like that. Okay, so that is going to be pretty good. Now let's go ahead and just set the servo to kind of the 0, 0 position to start in the center. So I'm going to go ahead and say pan servo dot angle, or the pan servo, or let's just call it pan angle. We're going to start the angle at 0, and then the tilt angle is going to be 0 equals 0. And then what we're going to do is we're going to say the pan servo dot angle is going to be equal to the pan angle, and then the tilt servo dot angle is going to be the tilt angle. Okay, so again, we're just trying to get our variable set up. And I think I'm going to go ahead and run this just to make sure that that comes on, and we should see this thing kind of aligned to the center if it isn't already. So we go, okay, boom, tilt servo is not defined. What did I do? I said pan servo and then tilt servo. Were you guys yelling at me? I'll get my game going here in a minute. Okay, so there. All right, so that's working. And then if I look here, okay, I am tracking. And even though it's finding some yellow in my coffee, it's not tracking that because we're only looking at the largest servo from last week, okay? Maybe I should move my coffee out of the way. Okay, so that looks pretty good. We've got that all set up and working. And now what we're going to need to do is those variables on that picture. So we have the width of the frame is W uppercase and the height of the frame is H uppercase. And so I need to go ahead and set up those position variables from our drawing. And so the X frame center is going to be equal to what? The integer value open W minus 1. Okay, we've talked about that a lot. And then we're going to divide by 2. Okay, now the Y frame center is going to be equal to the integer value of the height minus 1 divided by 2. Now we have the position of the center of the frame. Now we also need to get set up the X box center, and I'm just going to make that X frame center just to give it, start out with them in the same place because I don't know where it is because I haven't looked at it yet, but we'll just sort of set it to both the same. Y box center is equal to Y frame center. Okay, Y frame center. All right. Now let's run that, just make sure we haven't introduced any errors. This is a little bit of a tedious program, so I kind of want to debug as I'm going. Looking good, looking good. We are doing good so far. And so now we have those variables set up. So the next real action is going to come down in our while loop. Okay, it's going to happen down in our while loop. And so we're going to come over here, and we've got the box drawn. Okay, we've got the box drawn. I jumped over it. That's mouse action. Now let's go down to the while loop. Okay, so we've got our contours, and if we have a contour, we are going to find the largest one, and then if it's bigger than 150, we are going to draw a rectangle around it. Okay, we're going to draw a rectangle around it. So now what we're going to need to do is after we let me just think here a second. Okay, if we have a contour, and if the contour is greater than 150, okay, that is going to be where the action happens. Okay, so what I'm going to do is I get the bounding box, and then I draw the bounding box. Now I need to find the center of the bounding box. At this point, I should have everything I need to calculate the actual center of the bounding box. So that's going to be x box center, and that's going to be equal to what? The x value of the upper left corner plus the integer value of the width of the box, not the width of the frame. The width of the box is what? Lowercase w that we got here divided by 2. Okay, w divided by 2. All right, now we need to get the y box center. And go back and look at that picture, and this should make sense because we drew this on the picture. So that's going to be equal to little y, which is the y value of the upper left corner of the bounding box, plus the integer value of little h divided by 2. Okay, now I should have the center of the bounding box and the center of the frame. Now the center of the frame doesn't change, so I don't have to do that every time. But now I need to find out how far am I off in x. The x error is going to be equal to the x box center minus the x frame center. That's how far I am off left and right in pan. Okay, how far am I off in y? The y error is going to be equal to the y box center minus the y frame center. I'm going to run it just because, like I say, with these things that are going to get kind of complicated, we want to make sure we're not doing anything to mess things up. Okay, we've got those errors calculated, and so now I just kind of want to look and see where I am. So I'm going to go ahead and I'm going to put a circle in the middle of the frame, and so I'm going to say CV2.circle. And then where do I want that to be? I want it to be on the frame, okay? And then what is its location? It is the center of the frame. So that is going to be x frame center, comma, y frame center. And notice that this wants a tuple, so that is the xy coordinate is inside of the parentheses. And then let's go ahead and let's make that a radius of 10 pixels. We should be able to see it well. Let's make it blue, which would be 255, 0, 0, and let's make it a solid circle, which would be -1, like that, okay? So now with that, we should have it working with a dot showing us the center. And that did not work. Why did that not work? Oh, I know why it didn't work, because it only puts it there if it has a target, okay? So when it sees the target, there it is. So you see, I'm not over the target. I want it right here, and I'll have to move the servos. But it's also useful if we put a circle in the center of the bounding box. So the CV2.circle, that one is going to go on the frame, and this time it is going to be X box center and y box center. And I think that on this one, we want to make it an open circle. And as we're doing this, what you have to see is you cannot try to drive that error all the way to 0, because you can only move by 1 degree. You cannot move by less than 1 degree. And if you move the servo by 1 degree, you jump something like 35 pixels. And so I want to make good enough to be 35. So I want the radius of the center of the bounding box to be 35. And once the solid blue dot gets inside the larger red dot, don't try to go any further. Otherwise, you'll track, and then when you've got it, you'll go left, right, up, down, because you're trying to drive out an error that is smaller than your minimum step size. So that I have found out is about 35 pixels. And so now let's make that one red. So that would be 0, 0, 255, like that. And then let's make that a thickness of 3. We don't want that to be solid because we want to see the blue dot back behind it. So now what we should do is we should be able to get our thing. Okay, so you see, let's make sure that's working. So you see the red circle moves with the bounding box. And what do I want? I want to move the servo until I get here. Now, if it's here, I would move it. But if it's here, it's hard to do this. If it's here, I would not go any further because as long as I'm in that red circle, we're going to say good enough. Okay? So now that is good. So you see, it's like 90% of the job was drawing that picture. 90% of the job was drawing the picture. Now, if the x error is greater than or equal to 35, then we want to move the servo. But also, if it's less than negative 35, because you see it could be down here and the error could be negative. So in either case, if the absolute value of the x error is greater than 35. That means either you're too far to the right by more than 35 or you're too far to the left more than 35. That would correspond to about 1 degree. Okay, so if the absolute value of the x error is greater than or equal to 35. Now you have to think, am I too far to the right or am I too far to the left? Because we do different things. If the x error is greater than or equal to 0, that means I have a positive error. Then what do I want to do? I want the pan angle to be equal to the pan angle minus 1. So if pan angle is too big, I want to make it smaller. And then what will I do? I then apply that to the pan servo dot angle. And then what do I want to do? The new pan angle. Now, what is going to happen if the x error, it's too far to the left? It is less than or equal to, I'll just say less than 0, because really we don't do anything if it's equal. So it should be either greater than 0 or less than 0. So if the x error is less than 0, then what am I going to do? Pan angle is going to be equal to pan angle plus 1. Okay, so if I'm too far to the left, I want to come that direction. Okay, I want to come that direction. If I'm too far to the right, I want to make the pan angle smaller. And go back and look at that picture I drew, and it should make sense. So now the pan servo dot angle of pan angle again. This time we should get some action. Okay, this time we should get some action. Pan action, no tilt action left yet. Okay, and so now look at that. Okay, so you see it's lining up left and right. It's tracking left and right. Okay, and sometimes I need to tune. I think what I need to do is I need to tune that value a little bit. So let's see. Okay, what is that telling me? I think that is telling me that I need to tune those values a little bit more. Okay, we'll come back and tune the values. What we could either do is we would need to either make the error a little bit bigger. Instead of 35, we might need to make it 37 because you see we're getting that jitter that we don't want. So we'll tune these parameters, but what you can see is everything is going the right direction. Everything is going the right direction. Now we want to do this same thing. We want to do this same thing again. All of this, okay? But we want to do it for the tilt. And so we'll just come here, and you know, you all know if you live by copy and paste, you die by copy and paste. But if the y error, the absolute value of the y error is greater than or equal to 35, then we want to see, is the y error positive or is the y error negative? And then this would be the tilt angle that we're going to apply to the tilt servo, and then the tilt angle, and then the tilt angle. Now, do you remember that strange way that the servo in Y, it's like down is a positive angle and up is a negative angle? And so that kind of flips things around on how our errors are done. So this should be plus and this should be negative just because of the strange way that they oriented the motion on the Y servo, okay, on the tilt servo, right? So that should go like that. And then let's go ahead and let's see, I'm going to make the error 37 because I was getting a little bit of jitter in there that I didn't really like. And then this will come to 37. So we're making sure that we are not trying to move when it is already as close as it could be. And we might still have to tune that in a little bit. So now let's run this thing. Okay. What? 37. If y error, if the absolute value of y error, this did not tab overwrite. So let's try this again. Okay, like that. Okay, so now that should be lined up. Let's try this. Okay, good news is it went to the center, and then now that it sees this, okay, it's making me, whoa. Okay, we have an error in there somewhere. So we have, if absolute value of y error is greater than or equal to 37, if y error, then we have tilt angle. Did you guys see that? Tilt angle. And then I didn't even change these things down here. Man, I told you that's the danger of copying and pasting. Okay, so I've modified all those to tilt and one more. Tilt. Okay, so here we go. Run. Okay, here we go. Okay, so we've got more jitter than we like, but the thing is moving. Okay. Now the other thing to notice is, now I'll move it a little bit out, and then you see it's doing its best to get it in there. Okay, it's still, I think these numbers need to be bigger unless I have an error in there. But I think that what I've got to do is I've got to make this like up to, let's make it 40 and see if that works. And then this will be 40 and the radius will be 40. So what that's saying is that 1 degree of the servo is moving that picture by more than 35, and therefore it's going plus minus where it needs to settle down. And so we've got to kind of set this. Now you see, I'm always wanting to make that as small as possible because I would love for the blue dot to be in the middle of the red dot. I would love to have a servo that I could move to like 1/10 of a degree. Okay, but right now we've just got to kind of play with it so that we get rid of that instability. Okay, so I'm going to go ahead and put this here, and then we're going to run it. That is working pretty good, isn't it? Okay. Let's see if it works better like this. Okay, I'm trying to think what I can do now. Part of it is that if the bounding box is changing, then that's going to confuse it as well. Let me see if I can put a little bit of a delay in there, because sometimes if it's moving, it gets a little jitter, so we import time. And so let's see if I put a little bit of a delay in after I move the servo. A little bit of a delay after I move the servo. You see, it's working, but what I want to do, and it was working better earlier, but let's see if I can slow this down a little bit to give it time to settle after I move. And so after I move, I'm going to do a time.sleep of 1/10 of a second. Let's see if that helps it. And then here, time.sleep of 1/10 of a second, and time.sleep of 1/10, and then time.sleep. Okay. Okay, let's see if that settles it down any. So we start. Okay, here's my object of interest. No, okay, that sure settles it down. Okay, so you see it's moving too fast and it's jerking. But what is the problem? I've really slowed this thing down. Okay, so let's see if I can make this. Let's say if 0.05. So you see, we're going to have to play with these because it fixed the problem that if that thing's moving around, it's not getting, it's kind of capturing an image in the middle of a move. And so I'm trying to get this thing to settle down, but I didn't like how slow it became. So let's try it like this. So you see, this fixes it, and it's still going at 30 frames per second, which is good. But now you see, I'm not happy with the speed. I've slowed it down too much. And you see how it's always getting the blue dot inside of the red dot, which is great. Okay, so that's good, but we're going to have to slow it down. We're going to have to not slow it down so much. So let's go 0.01, 0.01, and 0.01, like that. Now let's try that. Okay. So now it's moving nice and fast, but it's still got a little bit of that glitch in it. Okay, so that, we're going to go back a little bit. Let's go back to 0.02, 0.02, 0.02, and 0.02. And let's see if we can find a sweet spot in here, okay? I am pretty happy with this. I'm running at 30 frames a second and the thing is tracking. And we're getting very little glitch. Now you see I'm moving it diagonally. And you see, you can see me here moving it. If you get it off the screen, you've got to help it come back. Okay, I am going to call that a success, all right? Now, there are fancier ways that you can do this, but this is the easiest way to think about it. And maybe what I'll come in and next week, I'll show you how we can come up with a little bit better of an algorithm. Okay, we can come up with a little bit better of an algorithm on the on the motion of the servo. And that's what I'll show you next week. Basically, what we're going to do next week is, rather than move 1 degree at a time, the amount that we're going to move is going to be proportional to the error. So if I'm way far off, I want to take a big step and then a smaller step and a smaller step to zoom in on it. And so that is what we will do next week. But I am just pretty darn happy with this. You see, it always gets the blue dot inside the red, and then it stops. And we're getting very little jitter now, very little jitter. Okay, guys, this is pretty cool. I really think that this is cool. Let's see if we can just set it down here. Oops, now it's going to find the desk. It's found the desk is yellow. So I didn't really tune out the desk. Come on, you aggravating thing, get up. Okay, there it is. Okay, there it is. So you see, it keeps the blue dot inside of the red dot, and it is really working pretty well. Let me see if I can just look at this and see. It has 27, 29, 27, 29. So let's see what we set that to. See if we could zoom that in a little better. Yeah, we went down to 25, so that should be good. So I think that we have it. I think that we have it pretty good as far as tuning in on that yellow. Now, what would we love to have here? All of our problems would go away if we had a servo that would do better than 1 degree. But I don't know if those servos exist. Okay, guys, I think that is really good. Let's put this back up here. Okay. All right, guys, this is a pretty big step. This is a pretty big step forward. I hope you guys are posting your homeworks to YouTube so I can have a look at them. Was this too big of a step for you? Let me know. I really want to know, were you guys able to do this on your own, or did you just get completely confused? I guess what you could say in the comments down below, that you were not able to do it, but when you see my solution, you think it's fair, or you could tell me that you think that I ask you to do too much based on the information I given you, that I should have taught you more before I gave you something this hard. But really, this is going to be something that we're going to continue to do, because we're going to want to track different things. Maybe we'll learn to track a face, maybe a hand, maybe a banana. We're going to trace objects, and it's always going to be this idea of driving the error out. And this time we didn't do a fancy way to drive the error. It's just, if the error is too big, then, decrement the angle. If it's less than 0, then increment the angle. And then we just drive the error out 1 degree at a time. Okay, guys, I do hope that you are enjoying this. I am having a whole lot of fun with this class. And I think what I'll do for next week's lesson, I'll try to go in and put in proportional control, where the amount that you move is going to depend on how big the error is. And if you have a really big error, you're going to move more than 1 degree. If you have a really small error, then it'll naturally stop trying to move, because you'll be trying to move it by less than a degree. And so we'll try to do that next week to get a little bit, what would I say, a little bit smoother action as it comes down to stopping. And you can see right now it's not always stopping perfectly. Okay, guys, I hope you are having as much fun with this as I am. It's at this point in the program, I always give a shout out to my Patreons. I would not be able to produce this quality, in-depth content every single week without the support of my Patreon. So big salute to you guys. You can help this video by leaving a comment down below and giving it a thumbs up. You can also subscribe to the channel if you haven't already. When you do, make sure you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people driving the AI and fewer people getting destroyed by the AI. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.